We will learn about a basic theory about moments now. So I think you have learned about this thing when you have P, two parallel forces, parallel like forces, which is that means both of them are going in the same direction. So if we have two forces parallel P and Q, the resultant will be P plus Q, and the line of actions will go through a point C which cuts AB such that this result, the resultant, will be much closer to the higher power here, the bigger force, right? So we have learned that, which means the C point, how do you find C point? The C point is such that P into AC is equal to Q into CB, right? This is how you find it. Now we'll talk about general principle of moment. Before we talk about general principle of moment, we'll discuss these basic principles. So if you have two forces like this, they say that the moment about any point by these two forces is equal to the moment at that point by the resultant force. So the algebraic sum of the moments by P and Q at O is equal to the moment by the resultant at that point, right? So how do we prove this? Let's find out the moment at O. So let's take the moment clockwise. So in this case there'll be moment by P. What is the moment? P into OA, right? What is the other moment? Moment by Q. Q means Q into OB. OB is the perpendicular distance. Plus, so both are in the same clockwise direction. Q into OB, right? So how are we going to prove this theorem? So let me change this. OA, P into OA, let me take OA. OA can be written as OC minus AC. So it's the same thing. I'm not changing anything. I'm just gonna write OA this side by using OC and AC. Why we are going to do it? Because I want to prove this theorem, right? You will see that at the end of this video. And Q times OB. How can we write OB? OB can be written as OC plus CB. OC plus CB, right? Okay, now collect terms of OC, which gives you P plus Q into OC. P plus Q into OC. And we are left with minus PAC plus QCB. So what is this gives you? You know from the earlier theory that PAC is equal to QCB, which means minus PAC plus QCB gives you 0. So you take this onto the other side, that leaves you with 0. So this becomes 0. So you are left with P plus Q into OC. Okay, what is P plus Q into OC? P OA plus Q into OB, right? So what does this tells us? So the algebraic sum of each of the forces about that point is equal to the moment about that point by the resultant, right? So this is the final result. So we can generalize this principle into any number of coplanar forces. So the general theorem, so general principle of the moment tells you that, so let's say that we have many number of forces in a plane, say, right? So we have F1, F2, F3. So likewise, so you get the gist. F4, right? If you have many forces on a plane, let's say you take a point, arbitrary point O, right? So which means now you can take moments by each of these force about that point. So let's say this distance is d2, and this distance, say d1. Now here let's say d4, this one let's say d3, right? So how do you find what is the algebraic sum of all these forces? Algebraic sum of the moments created by all these forces, that leaves you with F1 d1 plus F2 d2 plus F3 d3 plus F4 d4. I can go on, right? This is the algebraic sum about O in this direction, right? So this is equal to the resultant, not the resultant, sorry. So let's say the resultant of each of these forces goes like this. So this is the line of action of the resultant force. Let's say the perpendicular distance to that line of action from the point O is d. So general principle says that the algebraic sum of the moments by each of these force is equal to the moment created by R about that point, R into d, right? So this is the general principle of moments. Okay, you will see this principle, you will use this principle in many of the questions. So please make sure that you know this. Okay, thank you.